Let's jump right in. Today in this explainer, we're unlocking one of the absolute most powerful strategic concepts in all of cybersecurity, and that is defense in depth. Look, this isn't just academic theory, it is a total paradigm shift that will completely transform how you design and build applications. We're moving far away from that fragile, single-layer security model, and we're going to learn how to build truly resilient systems where the failure of one single defense absolutely doesn't spell disaster. Let's get to it. Here is our roadmap for today. We'll kick things off with the castle strategy, then map that to modern web application layers. After that, we'll dive into the assume breach mindset, walk through surviving real-world attacks, and finally, test your knowledge. Section 1, the castle strategy. Okay, so the crucial takeaway is right here. Defense in depth is a strategy using multiple, independent layers of security controls. Now, why is this absolutely essential? Well, because there are zero silver bullets in security. None. Eventually, some layer is going to fail. Firewalls get misconfigured, passwords get stolen in phishing campaigns, encryption keys accidentally leak from a config file. If you rely on just one single defense, you are literally one mistake away from a total system compromise. But by layering these controls, a single failure doesn't mean your entire application collapses. This is honestly the perfect way to visualize it. Think about it. You don't build just one single wall for a medieval castle, right? You've got an outer wall, a moat, an inner wall, a keep, and patrolling guards. Every single layer slows the attacker down and cranks up the chances they get caught. Now map that directly to a modern app. Your outer wall is your network perimeter. Your moat is the detection layer. That inner wall, that's identity and access. The keep is your data protection. And those guards are your logging and monitoring tools. This combination forces an attacker to defeat every single layer simultaneously, which is exponentially harder to pull off. Section 2, modern web application layers. So let's take a top-down view of the 6 core layers of a modern web application defense. Starting from the outside, we have the network firewall and DDoS protection. Moving down to the web application firewall, then authentication, authorization, application controls, and finally, encryption at the core. Let's break these down to see exactly how each layer tackles a completely different type of threat. All right, layers 1 and 2 are your perimeter defenses. This is your outer wall. Network firewalls restrict access based on IP and port. DDoS protection scrubs out massive waves of attack traffic. And your web application firewall, your WAF, inspects the HTTP traffic for common exploits like SQL injection and cross-site scripting. But remember our golden rule. No single layer is perfect. Attackers can definitely bypass these. They might use clean cloud IPs or exploit subtle business logic flaws that look exactly like perfectly legitimate traffic. Perimeter defenses are a fantastic first line, but trust me, they are completely insufficient on their own. So what happens when they actually get past that perimeter? That's exactly where layers 3 and 4 step up: identity and access. Authentication verifies who the user is. And ideally, you're using multi-factor authentication here, so a stolen password isn't game over. Then, authorization verifies what that specific user is actually allowed to do, checking resource ownership and strictly enforcing least privilege. This is a big one. If an attacker breaches the firewall, strong granular authorization on every single endpoint is what actually stops them from doing any real damage. And finally, we reach the keep, layers 5 and 6, application and data. This is where you enforce input validation, output encoding, and use parameterized queries to stop injection attacks dead in their tracks. And layer 6 is encryption, both in transit and at rest. Just think about this for a second. If an attacker somehow bypasses the firewall, steals a valid session, circumvents authorization, and gets direct access to your database, encryption ensures that all they walk away with is a bunch of useless ciphertext. That is the sheer power of layered defense. Section 3, the assume breach mindset. Design systems as if attackers are already inside. This is what we call the assume breach mindset, and I really want to be clear here, this is not pessimism. It isn't defeatism. It is pure, realistic pragmatism. Instead of solely asking, how do we keep everyone out, you have to start asking, how do we limit the blast radius when they inevitably do get in? Perfect prevention just doesn't exist, so our focus has to be on resilience. So how do you actually translate this philosophy directly into your daily coding habits? Well, you don't just rely on front-end validation, you validate input everywhere. You don't just check authorization at the login screen, you check it on every single endpoint. You encrypt your sensitive data, and you log security events constantly. You should always be asking yourself, if this single control fails right now, what else is protecting me? And if your answer is nothing, or maybe I just hope they don't find this endpoint, you need to add another layer. for sure.
Section 4. Surviving real-world attacks.
Let's look at a quick scenario without defense in depth. Imagine an app that only relies on basic authentication in a firewall. Step 1, an attacker phishes a user's password. That's one layer down. Step 2, they just log in. They bypass the firewall entirely because, well, it allows standard web traffic. Step 3, they start enumerating user IDs in the URL. Because there are no authorization checks, they can just view thousands of profiles they don't even own. Step 4, they dump the completely unencrypted database. It's fast, brutal, and totally over. A single phished password led to a catastrophic, uncontested compromise simply because there were absolutely zero backup layers.
Now, let's contrast that. We'll run the exact same attack, but this time, the application was built with defense in depth. Step 1. The attacker logs in with a phished password and a stolen MFA code. They're in. But watch what happens next. Step 2. They try to enumerate user IDs, but the web application firewall spots the unusual request rate and immediately rate limits them. Step 3. They try to access another user's profile, but Layer 4 authorization checks kick in and block access because that user doesn't own that resource. Step 4. All those authorization failures hit the audit logs, triggering an immediate flashing red alert to the security team. The attack basically hit a brick wall at Layer 2 and was completely neutralized by Layer 4, and that is exactly what we are aiming to build.
Section 5. Test your knowledge. All right, question 1. Let's see where you're at. What is the primary principle behind defense in depth? Is it A, strongest possible single defense, B, multiple independent layers, or C, rely entirely on encryption? Think back to that foundational castle strategy we discussed at the very start of this explainer.
If you guessed B, you've got it. The answer is to use multiple independent layers of security controls. Real strength comes from layers compensating for one another, not from crossing your fingers and relying on one perfect, impenetrable wall. Question 2. Which of these is not a typical layer in a defense in-depth strategy? A, network firewall, B, code obfuscation, C, authorization, or D, encryption at rest? Which one of these is the fake security control?
The answer is B. Code obfuscation is not a security control. It might slow someone down for a few minutes, but it provides absolutely no meaningful security compared to genuine, robust layers like firewalls, strict authorization, and actual data encryption. And our final question, what exactly does the assume breach mindset mean? A, assume security is futile, B, design as if attackers are already inside, or C, assume developers will introduce vulnerabilities. Remember that crucial philosophical shift we talked about earlier? The answer is B, design systems as if attackers are already inside. Embracing this specific mindset is exactly what drives the implementation of things like network segmentation, least privilege, and continuous monitoring. I want to wrap up this explainer by leaving you with this final thought and this specific number: 0. There are 0 silver bullets in cybersecurity. Literally every single control has weaknesses. So I want you to look at the code you are writing right now and ask yourself, if your primary defense fails today, what happens to your application? If the answer is disaster, it's definitely time to start building your layers. Thanks for hanging out with me for this explainer, and keep building secure systems.